We will see in this video how to use algebra in order to solve word problems. And we take the following example. The sum of two numbers is 49 and their difference is 19. Find the numbers. In this case, we have two unknowns that we have to find, two variables. And the statement at the end, the question of the problem, gives me the idea that it's about two variables that I need to find. Therefore, I will call them x and y. And I will say let x and y be the two numbers. It is essential to start by defining my variables, x and y, by telling what they represent, so that when I focus at the many steps that I need to carry, I don't forget actually what was my starting point. And now I'm going to start to build equations which will give me x and y. And the equations will be built from the information given. As we saw before, algebra is just a language. And I need to know how to translate the real world problem into the language of algebra. So it's like translation from one language to another. Let's start to read the problem. The sum of the two numbers is 49. Sum means x plus y. The sum of the two numbers is equal 49. And this is my first equation. What other equation I see here? The difference is 19. See, is tells me that I have another equation. Difference means subtract. So now I have two equations with two unknowns. And I can use either substitution or elimination. In this case, I think it's easier to use elimination, because I can add the two equations. As you see, I have one plus y and then minus y. So when I'm going to add them, y will cancel. Y minus y will give me 0. So if I add the two equations, I get 2x equals 49 plus 19 is 68. I can divide both sides by 2. Therefore, if I divide both sides by 2, I will get x equals 34. I substitute x into, let's say, equation 1, and I get 34 plus y equals 49. To find y, I take away 34 from both sides. So I get y equals 15. My solution is x equals 34, y equals 15. I will check sum of the two numbers. 34 plus 15 is 49. Yes, 34 plus 15 is 49. Difference, 34 minus 15 is 19. Yes, this is correct as well. So my solution is correct. So my answer to the problem is the two numbers are 34 and 15. And see, here we have a guide of the step that I'm following. Decide on the two unknowns. Call them, let's say, x and y. Do not forget the units. In the case we have units, so that's my first step. We start here. Write down two equations connecting x and y. If you have two variables, you need two equations. And you write the two equations by reading the problem and trying to translate from English to algebra. Solve the equation simultaneously. You choose elimination or a substitution. Find the solution, check your solution with the original data, and give your answer in sentence form. These are the steps. Let us now look at problem number 2. You can pause the video and read the question. The question says the average of two numbers is 20. If one of the numbers is double and the other is triple, the average increases to 52. Wow, that's a lot of information. But if I'm looking at the last statement, find the numbers, this gives me the idea of what I need to find. So I'm going to say, let x and y be the two numbers. And then I'm trying to translate, I will try to read the information given and translate it into the algebra language. The average of two numbers, average is x plus y divided by 2. That's you calculate average, you add and divide by 2. Is 20. Is 20. And this is my first equation. And I have another information given. If one of the number is doubled, so my first number becomes 2x. And the other is tripled, means 3 times 3y. The average increases to 52. So the average will be 2x plus 3y over 2, that's the average of two numbers, is 52. And now I have my two equations. Yeah, they look a bit maybe challenging because they have fractions, but if half x plus y is 20, it means that x plus y is 40. If half of 2x plus 3y is 52, it means that 2x plus 3y will be 104, will be 52 times 2. So 2x plus 3y equals 52. 52 times 2, so 104. I like very much the elimination method, but I can't eliminate because I have different coefficients. So I'm going to try to eliminate x. Doesn't really matter what to eliminate. So I multiply the first equation by 2 first to get the same coefficient here. If I multiply all sides of the first equation by 2, I get 2x plus 2y equals 80. And my second equation is 2x plus 3y equals 104. I'm almost done. I will multiply everything in the first equation by minus 1 to change the sign, because I would like to have minus 2x here, and add with 2x will give me 0. So changing all the sign in the first equation will give me that minus 2x minus 2y equals minus 80. And the second one is 2x plus 3y equals 104. Now adding equation 1 and equation 2, I will get minus 2x plus 2x will give me 0. Minus 2y plus 3y is y equals 104 minus 80 is 24. So I got y. Well, actually I was lucky to get it immediately. Substitute. Now substitute y equals 24 into that equation here. Seems to be the simplest. That's what connects x and y. So I'm going to put 24 here instead of y. So I get into x plus y equals 40. Unfortunately, I didn't give it a name, so that's why I can't call it. So I just copy it. So if I substitute, I get x plus 24 equals 40. Subtract 24 from all sides. Therefore, x equals 16. So my solutions are x equals 16, y equals 24. You can check the two answers. The average of 16 plus 20 and 24 is 16, or 24 over 2. And this gives me 40 over 2 is 20, correct? One of number is doubled. 16 doubled give me 32. Other number is tripled. 24 times 3 give me 72. The average is 104 divided by 2 is 52. It's exactly 52. So my answer is correct. So the two numbers are 16 and 24. we are going to move to another problem. Looks different, but it's the same idea. You can pause the movie and read it. So, a visit to the cinemas costs 64 for a group of 2 adults and 5 children, 68 for a group of 3 adults and 4 children. Find the cost of each adult ticket and each children ticket. So here I have my two variables. Let x be the cost of an adult ticket and y be the cost of a child ticket. So these are my two variables. And now we are going to start to depict the information and translate into algebra. A visit to the cinema costs 64 for a group of 2 adults and 5 children. So an adult pay x, 2 adults will pay 2x. A child pays y, 5 children will pay 5y. And we see that together they pay 64. I'm looking at the unit, it's the same euros everywhere, so I don't need any conversion. Second bit of information tells you that you pay 68 for a group of 3 adults and 4 children. So 3 adults will pay 3x, 4 children will pay 4y, and together you pay 68. So now I'm going to solve the simultaneous equations. Let me label them 1 and 2. None of the coefficients is the same, 2, 3, 5, 4. So I'm going to, I don't know, maybe get rid of x. So I'll multiply the first equation by 3 and the second by 2 to get 6x here and 6x here. So multiply 1 multiplied by 3 gives me 6x plus 3 times 5, 15y equals 64 times 3, 192. 2 multiplied by 2 gives me 6x plus 8y equals 134. Now I have again two equations. I'll call them 3 and 4. I will multiply 4 by minus 1. Because I want to change all the signs, actually I'm interested to change this 6x into minus 6x so that when I add them, they disappear. Multiply by minus 1 meaning that I will change all the signs. I copy the first equation. I always go with both equations. So first equation, I leave it as it is. Second equation, minus 6x minus 8y equals minus 134. And if I add them now, I get 15y minus 8y gives me 7y equals 58. I have actually spotted that I have a mistake, so I'm not going to go back and delete everything, but looking back, when I multiply this equation by 2, 68 times 2 will give me 136. So I'll have here 136, and here I'm going to have, when I subtract 192 minus 136, I'm going to have 56. Therefore, y will be 8 euros. Now I substitute y equals 8 into, none of them is very simple, so I'm going to substitute into 1, for example, which is up there, and I get 2x plus 5 times 8, because y is 8, equals 64. So therefore 2x plus 40 equals 64. Take away 40 from both sides. So 2x equals 24, divide by 2, so x equals 12. Therefore, my answer is, you need to go back and check that all my calculations are correct. So my final answer will be, the cost is 12 euros for an adult ticket and 8 euros for a child ticket. Here is another example of another nature. For the parallelogram alongside, find x and y. So I still have two unknowns, x and y, and I'm expected to know the properties of a parallelogram. And these properties should be in terms of equal sign, right? I need equations. What do I know about the parallelogram is that opposite sides are equal. Therefore, 3x plus 2y must be 19, and x plus 3y must be 11. And these are my equations 1 and 2. Let's choose to eliminate x, because it's simpler just to multiply the second equation by 3. So multiply all sides of 2 by 3. And I get by the number 3. My first equation stays as it is. You need to go with both equations. If you don't change anything, you copy it as it is. My second will be 3x plus 9y equals 33. Now I have the same 3x here and here. One needs to be with minus. I will choose to multiply that equation by minus 1, because here I have 2y's and here I have 9y's. So I like to have minus 2y here instead of minus 9y here. My answer will still be correct, but I want to get as simple as possible calculation. So I label this 3 and 4, and I will multiply equation 3 by minus 1. And I get minus 3x minus 2y equals minus 19. My second equation is 3x plus 9y equals 33. And now I'm ready to add them. Negative 3x add 3x will give me 0. So I'll be left with 7y equals 33 minus 19 will give me 14. Therefore, divided by 7, I get y equals 2. Now to find x, I will need to substitute or replace y equals 2 into, well, which one is simpler? I have equation 1, equation 2 connecting x and y, 3 and 4. I'll just take equation 1, but it doesn't really matter. Into equation 1, and I get 3x plus 2 times 2 equals 19, because y was 2. So 3x plus 4 equals 19. One equation into one unknown, x. Take away 4 from both sides, so 3x equals 15. Divide by 3. Therefore, x equals 5. So my answers are x equals 5, y equals 2. Now in order to check, I see that 3x plus 2y is 3 times 5 plus 2 times 2. 15 plus 4 is 19, correct? And x plus 3y is 5 plus 3 times 2, because y is 2. 5 plus 6 is 11. So this is correct too. On the next slide, you have 3 more examples that are solved for you.